Session 1, Introduction to Prometheus. What we will learn in this session is the time series database. Introduction to Prometheus, installing Prometheus, basic concepts, Prometheus configuration, monitoring nodes, that is servers with Prometheus, and Prometheus architecture. So Prometheus.io downloads, and here you will see Prometheus latest edition. It was updated on 16th of August. From the GitHub with this path, tar-xjdef. So this will create a directory with this long name, Prometheus files. So ls-l, you can see that Prometheus file directory is created. I can remove this. This is no more needed. rm-rf. This file is no more needed to save space to keep my system clean. It's always recommended keep your system clean. We are following the conventional methods of Linux where the binary should go to user bin directory. User bin, prom tool and Prometheus. Created a user for this purpose, so we are changing the ownership. And that's our objective is etc directory. So etc prometheus.yml, this is your conf data for Prometheus system unit. We are going to create that. Maintain the formatting of YML. YML is a specific syntax. That spacing, you cannot press tab key here. This is a physical space. So the alignment and all that stuff, indentation is mandatory because it uses Python syntax. YML is similar to Python in terms of syntax, in terms of spaces and tabs and list items and all that. Save this file, which will have a username configuration file. How these systemd units are created, where we specify the unit name. Wants means this is a prerequisite. After the network started, only then you start this. Service name, user is Prometheus, we created, group we created, and this is executable file name what I copied to. The configuration file what I created. Storage, where it will be creating the storage. So web console. So this is the systemd unit file. Daemon reload. After that, this command enable -- now Prometheus. It will start Prometheus and it will enable Prometheus so that when my system starts, the Prometheus is already started. So I can check with systemctl status and Prometheus. That will show my Prometheus is up and running. Systemctl status Prometheus, my Prometheus is running. So all this is working as a proper Linux service now. By default, there is no RPM. It is not available as RPM, but we converted this into a typical Linux philosophy that data configuration data should go to a specific directory. Library should have the library files, and the system units must start in with the systemd enabled. Let me open the port -cmd -permanent permanent add port equal to. In fact, there are multiple ports I will be needing: 8080, 9090, 3100, 80. All these ports I will be needing. So I'm doing in one go. 8000. I can open multiple ports in one line using curly braces, but then all the ports should be given without any space. So 9090 port number is added, and I am going to reload the firewall now. Now I'm good. I can access it from my host machine. That's what I did. So 10.10.0.100 and 89090. My Prometheus will be available here, and I'm sure it is started. But let me check the IP address, IP space A. Did I change the IP address 10.10.0.100? So I need to able to ping this command cmd ping my machine. And if I'm not able to get the reply, that means my host network adapter is not configured properly. So it is not able to reach. So it is a network issue. So how do I resolve it? I have to power off my machine. Right click on the machine, go to the settings. Under network, if you notice, my adapter was adapter number 3 with IP address 10.10.0.100. Take a look, a close look. This was adapter number 3. So my machine should have the same adapter, and that was the error in my case why I was not able to access. So network adapter number 2, and here it should be adapter 3, because this adapter in my case has the IP address 10.10.0.100, and then start the machine. And this time I don't have to wait. I'm pretty sure the moment my machine comes, I will be able to access my Prometheus at this IP address. By the time we complete the lecture, we will see our installation. So, however, I will discuss the binary file also. So, this is the agenda. What is time series? Imagine you want to know how the temperature outside changes throughout the day. Once every hour, you would check the thermometer and write down the time along with the current temperature. After a while, you'd have something like this. At 9 o'clock, it was 24 degree. At 10 o'clock, it was 26 degree. And at 11 o'clock, it was 27. So this is one example of time series where you have time and the values, a sequence of measurement ordered in time. Other example of time series can be CPU and memory uses over time, sensor data over time, stock market index over time. We cannot draw any conclusion from the data unless we visualize it, we plot a graph, or if not that, then we use some aggregate function like minimum, maximum, so basic mathematical function which are common. Combining a collection of measurement is called aggregation. There are several ways to aggregate time series data, like you can use average, you can use minimum, maximum, you know mathematical formula, you can calculate sum, and you can use count also, that return the number of values in the collection. The time series database, why we never store the time series data in Oracle or MySQL or traditional relational databases is this region. This slide will explain that what is the need of storing the time series data in a special type of dedicated database for that purpose. Why? This will answer that question if you are not aware. A time series database is a database that is explicitly designed for time series data. What is so special? Look at this example. This is a sequence of Unix timestamps 1572524345. Now if you look at closely, this is changing, last three digits are changing, rest all is same. If you see carefully here, so only last three digits are changing, rest all is same. So will be sheer wastage of space if I store all these values. That will not be optimal use of storage. If I store the whole bunch of data digits to my database, so they all start with this value 15725254. So therefore this will lead to poor use of disk space. We could store each subsequent timestamp as the difference also known as delta from the first one. Like if you look at the first value is this one is 345, the next value is 30 more than this, so we can use plus 30. The next value is 29 more than the first one, so you can use plus 29. Next is plus 30, plus 30. So this is the this will lead to better, not best, but better than the first one. If we take delta of deltas, we could take it even one step further by calculating the deltas of these deltas. That will make it plus 30, minus 1, plus 1, and 0. That means this is plus 30, 30 more than the first, and this 29 means 1 less than the first one, 1 less than previous, which is minus 1. Then next is 1 more than previous, that means plus 1, and this is same as previous one, so plus 0. This is a further reduction in space utilization. So this is the region that we have we require a dedicated storage for time series database, which will be optimized in terms of the storage. If measurements are taken at regular intervals, most of these deltas of delta will be 0. Another feature of time series database is the ability to filter measurements using tags. Each data point to each data point is labeled with a tag that adds context information such as where the measurement was taken. Here are some of the TSDBs supported by Grafana, like Graphite, InfluxDB, Prometheus. These are all time series databases. What is Prometheus? Prometheus is open source object written in Go language. Some of its components are written in Ruby also. This means that you have a single binary executable which I have downloaded and we are working on it now. Prometheus is fully Docker compatible and a number of Prometheus components within Prometheus itself are available on Docker Hub. Metric instrumentation means collecting metric. Metrics are primary way to represent both the overall health of your system and any other specific information you consider important for monitoring and alerting or observability. Prometheus is a leading metric instrumentation, collection, and storage toolkit built at SoundCloud beginning in 2012. I was delivering on Negios when they were building this. Since then, it's graduated from Cloud Native Computing Foundation and become the de facto standard for Kubernetes monitoring. Prometheus features is a multi-dimensional data model with time series data identified by metric name and a key value pairs. Prometheus query language PromQL, which we will discuss in a dedicated session, is a flexible query language to leverage its dimensionality. No reliance on distributed storage, single server nodes are autonomous. Time series collection happens via pull over HTTP. Pushing time series is supported via intermediary gateways. Targets means from where the data is available are discovered via service discovery or static configuration. Both options are available. In Kubernetes, we use service discovery, whereas standalone nodes and standalone application, we use static configuration. Multiple models of graphing and dashboarding support is available. The components of Prometheus are the server itself, that is Prometheus server, which scraps and store time series data. The client libraries are available for instrumenting the application code, meaning you are working on an application and you want this application to be monitored. So you can write at the time of development, you can instrument it, you can create data which you want is mandatory for monitoring purpose. You can expose the data right there at the time of development using client libraries. A push gateway for supporting short-lived jobs. Special purpose exporters like HA proxy, statsd, graphite, etc. are available. Exporter actually play a role in between. Like for example, I have MySQL database. Now MySQL does not expose any data for Prometheus. So what I can write is I can write intermediate software which will use a credential mechanism, permission authentication and authorization mechanism, and using this authorization it will pull the data from MySQL and it will expose the data at an external endpoint which Prometheus can go and scrap. So this in between steps we call it as exporter. It will be available to export the data from existing software which out of box does not support kind of metrics which Prometheus require. So to have this integration we create these exporters. An alert manager to handle the alerts. Obviously there's no point collecting metric if you don't have alerts configured on it, so we need additional tool. Actually it becomes a tool chain and various support tools also required. Download the latest release of Prometheus for your platform from this location which we have done, extract the file, go to the directory and configure this prometheus.yml file. Configuring Prometheus to monitor itself. Prometheus collect metrics from monitored targets by scraping metrics HTTP endpoints on these targets. Like this is global settings, scrap interval 15 seconds, external labels, then scrap configuration. This is job name. So we are going to add multiple jobs in our Prometheus throughout the training. So you'll have at least 4 or 5 of them during this training, because we'll be using Prometheus to scrap node exporter also, MySQL also. A lot of examples I'm going to demonstrate. So we'll be configuring that. So job name here it is configuring and monitoring Prometheus itself. Scrap interval 5 seconds, static configuration, and the data is available at 9090 port number. Since Prometheus also exposes data in the same manner about itself, so it can also scrap and monitor its own health. It's a good starting example to get started with Prometheus. Save basic Prometheus configuration in this file prometheus.yml. To start Prometheus with your newly created configuration file, change to the directory containing that binary and start with Prometheus -config file prometheus.yml. Definitely not ideal situation, not ideal way to start to monitor the things. Absolutely not. The ideal situation is you install Prometheus, put the right file at the right place, configuration data in etc folder, libraries to library, binaries to binary folder, and then create a system unit file, enable, disable, stop, start, and manage that the way you manage your other Linux systems and system the units. That's the right way to do it, and that's why we are doing it. So 2 approaches I have discussed. What is best for your environment, you can use that one. You should also be able to browse to a status page about itself as localhost :9090. Give it a couple of seconds to collect data about itself from its own HTTP metric endpoint. You can also verify that Prometheus is serving metric about itself by navigating to its metric endpoint like localhost 9090 matrix. So now I'm refreshing it without my even pressing enter key. It is available team. That's what I was talking about, because the region was this. So let's go to the matrix. So this is the matrix and this is the data exposing itself. And this is the metric name. This is the tag name, and this is the uh, parameter for the tag. A key value pair is the tag we specify in curly braces, and this is the actual value. So these are metrics monitored by Prometheus, and using some functions we can visualize this. This is the data exported. So we can also monitor plot graph. So we'll write queries here. This is the expression where we write shift plus enter for new lines, and just type the enter here and click on this graph to see the graph right now. Give it a couple of seconds to collect data, and then that's what we have seen matrix also. How it works. This is how Prometheus works, team. Prometheus server perform the retrieval of the data, go to the target and retrieve the data, and store the data in time series database on your hard disk. Whether it is HTTP server or retrieving by going to the target, like pull matrix. This pull means is going to the target, is going to the target to get the data, collect the data from the targets. It is not data direction, it's the direction of Prometheus going to the target. So if you are using short-lived jobs, we can configure a push gateway. And if we are using a direct exporter or direct available on a endpoint, so it can use jobs or exporters and Prometheus target. We call them as Prometheus target. Prometheus will go and scrap them and store the data in TSDB. We can use Prometheus query language to query this data. We also have a web UI, as you have seen in our case. We can also connect it with Grafana and visualize the data in Grafana, or we can also use API clients. Prometheus can push the alerts to alert manager, which can segregate, deduplicate, silence, and perform operations on the alerts. And based on the configuration rules, it can send the alerts to PagerDuty, email, etc. We can also configure service discovery, which will discover the Kubernetes cluster and will scrap the pods from the cluster. So we can monitor Kubernetes pods, we can monitor independent targets, we can monitor short-lived jobs through push gateway, we can send alerts to alert manager, we can use Prometheus query language to query it, we can visualize Grafana to visualize it. This is the big picture of Prometheus, where Prometheus is, what the roles Prometheus different components plays. Prometheus is configured via command line flags and a configuration file. The CLI flags configure immutable system parameters. The configuration file defines everything related to scrapping jobs and their instances, as well as the rules files to load. You can specify all of them using Prometheus-H. It can reload its configuration at runtime. If the new configuration is not well formed, the changes will not be applied. This will also reload any configured rule files. To specify which configuration to file to load, you can use --config.file flag at the time of calling it from the command line, or in the etc systemd system under that the service unit file which you have created. The file is written in YML format defined by schemes. Brackets indicate that a parameter is optional. For known list parameters, the value is set to specified default. The placeholders in the file, like for example, when you see boolean, means it's a boolean that can take value true and false. Duration, it matches the regular expression, which is like 0 to 9, any digit. Multiple number of digit, plus means one or more, then followed by y, that is year. So for example, here instead of 1 day we can start with, let's say, 9 year, 9y. Then question mark means 0 or 1 of previous character. So 0 or 1 means whether we have it or we don't have it, the previous word given in parentheses. Then 0 to 9 weeks, then day, then hour, then month, then seconds. The same is repeated. So in a way it is a regular expression for time. And this is one example: 1 day, or 1 hour 30 minute, or 5 minute, or 10 second. All these follow this regular expression. File name is a valid path of current working directory. Host is a valid string consisting of a host name or IP followed by optional port number. Integer is an integer value. Label name is a string matching the regular expression. Label value is a string of Unicode characters. Scheme is a string that can take the value HTTP or HTTPS. Secret is a value string, regular string that is secret, such as a password. Template string is a string which template expanded before the uses. Scrap config, we specify where we specify set of targets and the parameters describing how to scrap them. In general case, one scrap configuration specify a single job. In advanced configuration, this may change. The targets may be statically configured via static configs or dynamically discovered using one of the supported service discovery mechanism. Additionally, relabel configuration allow advanced modifications to any target and its labels before scrapping. Then TLS config option in the Prometheus.yml file. If you are using TLS certificate, you can use TLS configuration. These are all configuration options in the Prometheus.yml file we are discussing. It is a TLS config that allow configuring TLS connections to your Prometheus endpoints. Similarly, this SD config, this is file-based service discovery. The SD stands for service discovery. It provides a more generic way to configure static targets and serve as an interface to plug in custom service discovery mechanisms. It reads a set of files containing a list of 0 or more static configurations. Changes to all defined files are detected via disk watches and applies immediately. Files may be provided in YML or JSON format. Only changes resulting in well-formed target groups are applied. File must contain a list of static configuration using this format, like we can have JSON format or YML format. Kubernetes service discovery configuration. Kubernetes SD configuration allows retrieving scrap targets from Kubernetes REST API and always staying synchronized with the cluster state. Static config. A static config allows specifying a list of targets and a common label set for them. It's a canonical way to specify static targets in a scrap configuration. And this is how we specify the target, and this is one example, and we can specify the labels also, label name and the label value. Coming up next, session 2 will be monitoring using Prometheus, and you can explore the configuration section of Prometheus online documentation. The link is given here. That's all for this session. Thank you very much, team.